Part A, let's find f plus g of 4, f minus g of negative 2, f times g of 1, and f over g of 0. We'll find f plus g of 4 first. By definition, this is f of 4 plus g of 4. And we'll go to the graph to find out what f of 4 is. F of 4 means plug in a 4 into the function, and what is the output or the y coordinate? And we have the y coordinate is 9. So f of 4 is 9. G of 4 means plug in 4 into the function g of x. And what is the x coordinate produced as an output? If I plug in 4, the output is 2. So f plus g of 4 is just 9 plus 2, or 11. F minus g of negative 2 is equivalent to f of negative 2 minus g of negative 2. We'll look for f of negative 2 first. We'll plug in a 2 and see what the output is. The output here is negative 3. So f of negative 2 is negative 3. You're going to subtract g of negative 2. And if I look, g of negative 2 is undefined. There's no value for g of negative 2. That's undefined. So this whole thing is going to be undefined. We cannot figure out that value. F times g of 1 now. Let's find f times g of 1. This, by definition, is f of 1 times g of 1. So we'll locate the function f, and we'll plug in a 1 into it. If I plug in a 1, the output is a 3. So we know f of 1 is 3, and we're going to multiply that with g of 1. If I plug in 1 into the function g, I get the output, or the height, is 1. So f times g of 1 is just 3. F over g of 0 is equal to f of 0 divided by g of 0. And f of 0 is just going to be the y coordinate when you plug in a 0. So it's a 1. F of 0 is 1 divided by g of 0, and g of 0 is 0. But wait, you cannot divide by 0. This is undefined. In part B, we're going to evaluate this expression for certain values in a table. So let's try f plus g of 4. F plus g of 4 is equal to f of 4 plus g of 4. I'll look for the function f of 4. When I plug in a 4, the output for function f is 9. So that's 9. If I plug in a 4 into the function, the output for g of 4 is 2. So we get 9 plus 4 is 11. Now let's try f minus g of negative 2. This is f of negative 2 minus g of negative 2. And we'll plug in f of negative 2 into the function. As we can see, if we plug in a negative 2 into the function, we get negative 3. And we're going to subtract g of negative 2, but wait a minute, that's undefined. So that implies this whole expression is undefined. Let's try f times g of 1. This is equivalent to f of 1 times g of 1. And we'll plug in a 1 into the function value for f of x. That gives us a 3. And we'll multiply by g of 1. And if we plug in a 1 for g, we also get 1. So f times g of 1 is just 3. F divided by g of 0 is equal to f of 0 divided by g of 0. So we'll plug in f of 0. If I plug in a 0, I get a 1. And then I have to divide that by 0, and that would be undefined because we cannot divide by 0. Part C, now we're going to use f of x equals 2x plus 1 and g of x equals the square root of x to find these four values. We'll start by f plus g of 4, and that is equivalent to f of 4 plus g of 4. F of 4 means plugging a 4 into this expression, so that's 2 times 4 plus 1. And then we're going to add g of 4. So I'll substitute a 4 into the square root of x. Two times 4 plus 1 yields 9. And the square root of 4 is 2. And we get the same value as we did earlier. This produces an 11. We'll try f minus g of negative 2. This is equivalent to f of negative 2 minus g of negative 2. F of negative 2 means plugging negative 2 into the f function. 2 times negative 2 plus 1. And we'll subtract g of negative 2, which is the square root of negative 2. But you cannot take the square root of a negative. It is not possible. So f minus g of negative 2 is undefined. F times g of 1 is equal to f of 1 times g of 1. To find f of 1, we'll plug in a 1 for the function value f of x. 2 times 1 plus 1. And then we'll multiply that with g of 1, which is the square root of 1. We know this results in 2 times 1 plus 1, or 3 times square root of 1 is just 1. So f times g of 1 is just 3. F divided by g of 0 is equal to f of 0 over g of 0. And f of 0 is 2 times 0 plus 1. And we'll divide that by g of 0, which is the square root of 0. The numerator becomes 1, and the denominator is just 0. You cannot divide by 0, it is undefined. Let f of x be equal to 2x squared minus 3x. Find and simplify the expression for the difference quotient. Essentially, what the difference quotient is the slope of a secant line to a curve. A secant line is a line that crosses through 2 points of a curve. So this will allow us to find the slope of that secant line. We begin by writing the difference quotient. F of x plus h minus f of x divided by h. The first part of the problem is to find f of x plus h, which means I have to plug in x plus h into the x of the original function. This gives us 2 times, we'll plug in x plus h squared, minus 3 times, again we'll plug in x plus h. So the first part that we have done is just the f of x plus h part. We will now need to subtract f of x, and f of x is the entire function 2x squared minus 3x. So we're going to put subtract 2x squared minus 3x. Don't forget to put parentheses around f of x so we can distribute the negative throughout the right side. And finally, the equation requires us to divide by h, so we have the h on the bottom. If you look at x plus h squared, we're going to have to FOIL out x plus h squared. We'll do the scratch work somewhere on a separate piece of paper. X plus h squared is equivalent to x plus h times x plus h. If I FOIL this out, I get x squared plus xh plus xh plus h squared. This is x squared plus 2xh plus h squared. Now I can replace the x plus h squared with x squared plus 2xh plus h squared. So now we have 2 times, we'll replace the x plus h squared with x squared plus 2xh plus h squared. And we'll distribute the negative 3 to the x plus h. This gives us negative 3x minus 3h. And we'll also distribute the negative through the right side of our expression. Negative 2x squared plus 3x. This becomes a plus because of the double negative. And we still have to divide that by h. Let's distribute the 2 to the parentheses. And this gives us 2x squared plus 4xh plus 2h squared. And I'm just going to copy the rest of the equation. Negative 3x minus 3h minus 2x squared plus 3x all over h. We can simplify the numerator now. Negative 2x squared cancels out with 2x squared. 3x cancels out with negative 3x. This gives us negative 4xh plus 2h squared minus 3h divided by h. Notice that each of the numerators contains a factor of h, so we'll factor out h to the front. H times the quantity, negative 4x plus 2h minus 3 over h. The h's divide out, and our final answer is equal to negative 4x plus 2h minus 3. If f and g are functions, then the composite function or composition of f and g is defined by f of g of x equal to f of g of x. Notice we're taking the entire function g of x and we're plugging it into the function f. The domain of f of g of x is the set of all numbers x in the domain of f, such that g of x is in the domain of f. Example 5. Let f of x be equal to 2x minus 1 and g of x be equal to 4 over x minus 1. Find f of g of 2. F of g of 2 is equivalent to f of g of 2. So we need to find g of 2 first. G of 2 is equal to, we'll plug in a 2 into the function for g, 4 divided by 2 minus 1, and that simplifies to 4 over 1, or just 4. So g of 2 is 4, and we can plug that into our equation. F of 4 is equal to, now 2, I'm going to plug in a 4 into f of x, 2 times 4 minus 1, and that is 8 minus 1, or just 7. Part B, find g of f of negative 3. g of f of negative 3 means we're going to plug in the negative 3 for the function f, and whatever we get for the f of negative 3, we're going to plug that back into g. So we'll find f of negative 3 first. F of negative 3 equals, plugging in a negative 3 for the function f of x, 2 times negative 3 minus 1 equals negative 6 minus 1, or negative 7. Now we can plug in the negative 7 into our expression. Let f of x be equal to 2x minus 1 and g of x be equal to 4 over x minus 1. Let's find g of f of negative 3. G of f of negative 3 is equal to g of f of negative 3. So we'll have to find what f of negative 3 is first. F of negative 3 equals, we'll plug in a negative 3 for f, 2 times negative 3 minus 1, and that's equal to negative 6 minus 1, or negative 7. Now we can plug this into our function. So we have now g of negative 7 is equal to, we'll take that negative 7 and we'll plug it into the function for g. G of negative 7 is equal to 4 divided by negative 7 minus 1. Again, we're plugging in the negative 7 for the x. The denominator simplifies to negative 8. And our final answer is negative 1/2.